Okay, let's head on to the next question. So the next question is 3.1.6. 3.1.6, what do they have? So here they say there is no intervisibility between 8 in block D4 and 9 in block D2 on the orthophoto map. Name the type of slope responsible for this. So 8 in block D4 and 9 in block D2. So there we go, 8 in block D4 and 9 in block D2. So these are the 2 points that we are talking about here, 8 and 9. What are they saying? They're saying that there's no intervisibility. That means there's no ability to see someone who's there when you are actually here. Okay, so they cannot see each other because of something that has to be in the middle. In this case, it's the slope. Okay, and they want us to name this type of slope. Okay, now guys, there are many slopes, and slopes you identify slopes using using the arrangement of contour lines. Okay, and we have many slopes. Let me just give you a few examples. You'd have, for an example, the valley slope. Valley slope would have like V, it would have V kind of and very sharp, and it would have maybe a river running through there. Okay, so that would be a valley slope. Okay, you have a concave slope, you have a convex slope, you have a mesa. Okay, a mesa mesa is a flat-topped mountain. Okay, like for an example, your Table Mountain is flat-topped. It is more wider than it is tall. Okay, so excuse me, it is more wider than it is tall. Okay, as you can see, it's more wider than it is tall. Okay, and second of all, it has this cap rock here, so it gets steeper and steeper. So you'd identify it, of course, by having so this point, of course, would have very it would have contour lines that are very close to each other. Okay, and then of course when you get to this part, it would be it, because it is the slope is flat, is gentle, so it would of course be gentle. It would have contour lines that are far apart. Okay, so that would this also applies to the concave slope, right? Concave slope. Okay, but in this case, and you'd have of course your hills. So of course a hill has concentric contours like that. Okay, so what do we have here? So when we look at this, so I'm right here at 8, and I'm looking at someone who's right here at 6, at 9, right? So look at this, look at what happens here. So as you move towards that 9, you see that, okay, these contours are getting quite steep, are getting quite close to each other. So this means that you are the land is actually going up like that. Okay, so it is, as you're moving from 8 to 9, there's actually an obstruction in front of you. The land is going up because it is steep. Okay, so and also what do we see? Okay, so this would mean that it is flat topped. Okay, it is flat topped because the contour lines start to get further apart again when you get to this point. Okay, so it would look something like that. Okay, look something like that. Okay, now the question now is this a butte? Is it a mesa? So that's the question right there. Okay, so for a butte is much taller than it is wider. Okay, so a butte would be like, it wouldn't have this whole land that is flat, okay, because this means that this is quite wide, okay. This means that it is quite wide, okay. So what would we call this then? Okay, so this, for me, I would say it's a mesa or a mesa, okay. Because of course, we don't see valley, we don't see any valley, we don't see any river here. All we see is that as we move towards 9, as we move towards this area, we can see that the contour lines are close to each other, so this means that this area is going uphill. And then once we get to this point, moving here right along this path, you would see that, okay, the contour lines are far apart, and so this means that this is gentle. This is a gentle slope. So it is steep and then gentle, and it is wider. Okay, so we cannot say that it is a butte. Okay, so I don't know. I think you could get away with a concave slope, okay, because as you move towards the 6, of course, these contour lines get further apart again, okay. So you would say it's concave, but you would also say that this is a mesa, okay. So I don't know. I don't know what, of course, the memo says, but I would go with a mesa because this is much more wider. It has a cap rock, and it is flat topped, okay, as you can see, okay. So I would go with a mesa, okay. So for 3.1.6, so for 3.1.6, I would go for a mesa, okay, or a concave slope, okay. I would have also written a concave slope. So yeah, guys, let me know what you guys think. Yeah. So we move on to the following question, and that has to be question 3.2. Okay. Map interpretation. Okay, so this part, you have a cocktail of topics. Okay, you just have to apply your knowledge, what you know, in the context of a map. Okay, so you use your knowledge, so you use climatology, you use geomorphology, in order to solve problems here and answer questions based on those. Okay, so what do we have here? So 3.2 map interpretation. So of course we'll start on with 3.2.1. Okay, so 3.2.1 says map evidence indicates dash rainfall because of the dash blue lines on the topographic map. Okay, so it indicates dash rainfall because of the dash blue lines. Okay, so we are looking at this map. Okay, so let's take a look at the map again. We have 4 options on the question. So 4 Roman figures. The first one is annual, the second is seasonal, the third is continuous, and the fourth is dashed. Okay, so now what do we look for when we are trying to describe or trying to figure out the climate of an area? Okay, so in this case, for rainfall, what you look at, of course, you look at the type of rivers that you have here. Okay, so if you can like really look at these, I hope you did see them clearly in your exams. Like there's just a lot of seasonal rivers, okay, non-perennial rivers that are dashed. There's just only them in this. Okay, I don't see any permanent river here. They are all dashed, guys. Okay, so what does that indicate about the type of rainfall that they have? Do they have it annually or seasonally? Okay, so because these are seasonal rivers that we see here, and so we should be getting seasonal rainfall. Okay, so it has to be seasonal, and dashed. Okay, it's seasonal and dashed because the dashed lines, of course, tell us or convey to us that they are seasonal rivers. So because rivers are directly affected by the rainfall, and so of course the rainfall is also seasonal. Okay, so what do we have here? So what choices do we have? So A is Roman figure 1 and 3, B is Roman figure 1 and 4, C is Roman figure 2 and 3, and then D is Roman figure 2 and 4. So we are looking for Roman figure 2 and 4. Okay, so that has to correspond with D. So for 3.2.1, we are going with the option D. Okay, it's 3.2.1. Let's head on to the next question, 3.2.2. Okay, so okay, before we head there, they say refer to the encircled area G in block B1 on the topographical map. So let's look at the map in block B1, right? So this is block B1. So this is the encircled G. Okay, so this is what we're looking at here. Okay, all right. Okay, so this is the encircled area. Okay, what about it? So they say in 3.2.2, explain how the katabatic wind influences the temperature at G in block B1 on the topographic map. How does it influence the temperature? How does the katabatic wind? Okay, so if you can like clearly see here, going from this point going up towards G, on either side you have very steep slopes. Okay, so when you walk straight from this point, as you can see, you have steep slopes on either side. What does that indicate? We are in a valley, guys. Okay, steep slope on the left, steep slope on the right, steep slope on the left, steep slope on the right. So this is what? This is the valley floor. Okay, this is the valley floor. Okay, so this area is a valley floor, guys. And as we can see, okay, it is cultivated there. There is a river running down there. Okay, of course. So this is a valley. Okay, and this is the valley floor. Okay. So of course, if you have a valley, you are going to have cold winds sinking down due to the gravity, called heavy and dense winds. Okay, sinking down due to the force of gravity, and they collect there at the bottom, at the valley, right? So if you have cold air sinking down down the valley floor and collecting there, what do you expect? You expect the temperatures to be low. Okay, so of course our answer there, so the temperature, so katabatic winds, so let's say, okay, the temperature at G will be low because this cold dense air collects at the valley floor, which is where G is located. Okay, so of course temperature will be low because cold dense air, this cold dense air, which is katabatic wind, okay, collects at the valley floor at night. Yeah, and the valley floor, this is basically where G is. Okay, or maybe I could have just collects at G. Okay, Yeah, but I'm trying to explain that G is located there at the valley floor, okay, so that they know that I know. And also because it is located at the valley floor, we know that katabatic winds sink down towards the valley floor, okay, and so they meet there. And so of course they change temperatures there. They lower the temperatures of the valley at the valley floor, okay. Hope you guys do understand this. Okay, so that's the valley floor, and that is where cold air collects there at night. Okay, it's sinking. Okay, we know that katabatic winds, they sink. Okay. Okay, so that is 3.2.2. Okay. So right, 2 marks. Okay, so let's head on. The table below shows crops and the temperature at which these crops are likely to survive. Okay. Okay, so we have crops and their favorable temperatures, okay, the temperatures that they prefer in order to grow effectively. So we have pumpkin that prefers an average temperature of -2 degrees Celsius, and then tomatoes that prefer 5 degrees Celsius. Okay, so pumpkin prefers colder temperatures, and then tomatoes, of course, prefers comparatively warmer temperatures. Okay, so what's the question? What's the question that they are giving us? So for 3.2.3, they say which crop, pumpkin or tomatoes, is most likely found at G in block B1 on the topographical map. Okay, so G in block B1, as you can see, guys, we said that this is a valley floor, right? So if it is a valley floor and you are going to have low temperatures, okay, at the valley floor because of katabatic winds, okay, and we know that the valley floor is also susceptible to frost. Okay, this is also what we call the frost packet. Okay, so of course you'd want to have plants that prefer colder temperatures at the valley floor because that is where cold air collects, that is where frost is likely to occur. Okay, so which crop now is or will be favorable, okay, to plant on the valley floor? Okay, we said the valley floor is cold, and so of course we are going for the crop that prefers colder or lower average temperatures. Okay, in that case that is pumpkin. Okay, so for 3.2.3, I'll go with pumpkin. Okay, because tomatoes would be very bad if we're gonna plant them on the valley floor, which is a place where cold air merges or collects. Okay, so I'll go with pumpkin for 3.2.3. Okay, 3.2.3. I'm struggling here. Okay, so that's it. Okay, so let's head on for the next question. Next question says, give, so that's 3.2.4, says, give a climatological reason for your choice. Okay, why did I say pumpkin? Okay, so my explanation here, okay, I'll say G is located on the valley floor, where cold air collects. Okay, and that cold air, by the way, I'll just maybe, okay, I could have just put in brackets after cold air and say katabatic winds. Katabatic winds. Okay, it's not even in the middle, guys. In mid slope where you have the thermal belt. Okay, this is where warm air collects. This is where cold air collects. Okay, so That's why we are saying that we are going with pumpkin. Okay, so G is located on the valley floor where cold air collects and where frost forms. Okay, so pumpkins are likely to survive or to thrive in this in cold or low temperatures, or we can say and frosts are likely to thrive in these low temperatures. Okay, I'm sorry for like the mess, okay, but I just hope you see it though. Okay, that's how would have explained the formation or the preference of planting pumpkins and planting tomatoes. Okay, so that's 3.2.4. Okay, compared to the river at 10 on the orthophoto map. Okay, the river at 10. Let's look at our orthophoto map. There we go. This is the river that they are referring to. So this is this river. Okay, remember this is a picture. So this river, of course, looks like it runs from here and from here. I see this as a convergence. Okay, I'm not sure. Yeah, looks like that. Okay, that's the valley as well. So the contour lines also support this, that this is a valley. This is another valley, and this these two channels meet over here. Okay, and then it continues further on. I think from this direction. Yeah. Okay, that's what I'm. Yeah. Okay. Yeah, I see it. So 3.2.5 says the river at 10 on the orthophoto map generally flows in a southwesterly or northeasterly direction. Okay, southwesterly or northeasterly. Okay, now there are many ways that you can look at this, but in this case, we work with what we have. Okay, so what do we have here, guys? Okay, what we have here is contour lines. Okay, this is the height indicator, height indication. We said that this this is actually sloping down. Okay, from this point is actually the flat top point, and then it's okay, so it looks something like that. Okay, okay, maybe it's very bad. Okay, but it's actually like sloping down, going down from a high point like that. Okay, so that's basically what we see. Okay, it is sloping down. Okay, that means that because rivers always flow from high ground to low ground, then this means that it has to flow this direction. Okay, it's going southwesterly. Okay, so it's going southwesterly. Remember, for the winds, we would say the opposite direction, because it's different how we describe direction with winds. So we're going for, so for 3.2.5, we're going for southwesterly. Okay, that's where it's heading to. Then 3.2.6, give a reason for your answer. Why is it flowing southwesterly? I'm going to say contour lines indicate a decrease in height from the north, from north east of the river towards its southwest. And um, taking into account that rivers always flow from high ground to low ground. It has to flow southwestward. Okay, let's head on to the next question. 3.2.7. Refer to the river at H on the topographical map. Okay, so at H, so there we go. This is our H, guys. My phone just cannot zoom in, but this is the river at H. Okay, what about it? So 3.2.7, they say in which stage, okay, upper course or middle course is the river at H in block C3 on the topographical map. So in which stage is the river at H? Okay, so this river, but in block C3. Let's look at block C3. So this is 1, 2, 3, and that is C. Okay, so we are actually like looking at the river, this river. So I'm not sure how they connect though. The river at H, how does it connect? Because it goes down, right? How does it connect to river here? I don't see how it does, really. I really cannot see that, but we can look at what do we have at block C3 that indicates to us that this should be upper course or middle course. Okay, so first of all, what do we see here? First of all, we see cultivated land, right? So this is cultivated land, and you wouldn't have cultivated land on the upper course. You usually find cultivated land on flat-lying land. Okay, and so this means that the gradient here is quite it's quite gentle. Okay, except for this side, of course. But where the river runs along, it is gentle. Okay, so the river is quite gentle there. What else can we see here? We can also see that there is there's regional farms. Okay, there's a reservoir, there's hiking trails. And people once lived there somehow, because we also see ruins again there. We have ruins as well. What else is there, guys? I don't see anything else except for the contour lines that are far apart. This region, this is where the river runs. Actually, that's the river. I'm really sorry about this phone, guys. Wow. Okay. But I honestly don't know how they connect. Okay. I've been trying to track this, but no, I actually don't. Okay. So for this question, I would say that so for 3.2.7, I would say that it is in the middle course. Okay. Let's see what 3.2.8 has. So 3.2.8 says give evidence from the topographical map to support your answer. Okay. So the gentle, okay, so I'm just going to talk about the slope here. Oh my god, I should have said the slope is gentle. I'm looking at contour lines, far apart, and also looking at and there is cultivated land on the floodplain, or land next to the river at C3, suggesting it is on the floodplain. Floodplain. Okay, floodplain, which are usually on of course flatland or gentle land slopes. Okay, so let me know about this one, what you guys think. Okay, what did you see there that I did not see? I might have missed something. Here, guys. So for those that would argue my answer here, let me know what you would have written, okay, or what did you write. I might have missed something there, guys, I admit. Okay, so let's carry on then. Let's carry on to 3.3. that is GIS. Okay, so let's finish this up. So 3.3, that is GIS, Geographical Information Systems. Let's take a look at 3.3.1. Okay, so the environmental issue labeled I in block A2 is represented as a dash feature on the topographical map. Okay, so A, is it a point feature? Is it a polygon feature? Is it a node feature or a line feature? Let's first look at what are they referring to here. So in block A2, it's I. Okay, so let's take a look at that. What is this, guys? Okay, so of course let's take a look at this. For those that cannot see this, it basically looks like, so it's brown with these lines around it like that. Okay. Let's take a look at these. Okay, we have, oh, actually it's erosion, because they are mentioning an environmental issue. Okay, so that matches with erosion. Okay, right, yeah, that's erosion right there. Okay, it's not this. Okay, no, it's not this. It's not a dry pan, it's erosion, guys. So because it of course has space, surface space, we would of course have to go with a polygon. Okay, if it has space, then it is a polygon. Okay, so we cannot say it's a point, it's not a line, it's not a node, so we go with B. Okay, a polygon. Okay, so 3.3.1, we are going with B. Right, set on to the next one. 3.3.2. 3.3.2 says remote sensing is defined as taking images of the Earth's surface from a distance. Okay, yeah, that's the definition of remote sensing. What else? Explain how remote sensing can be used to effectively monitor, okay, the environmental issue mentioned in question 3.3.1. Okay, so the environmental issue, of course, is the soil erosion. We've already identified that. So they're asking us how remote sensing, how can it be used to effectively, okay, monitor, okay, the environmental issue. Okay, so to monitor is to regulate, constantly look at something, look at changes, look at what has changed. So how would remote sensing help us there? Okay, how would it be effective? Okay, so first of all, I would say that remote sensing allows us or let me rather say remote sensing covers very let's not say very, let's say large areas in real time, and also allows us to prevent or to avoid being in contact, or maybe disrupting, or let's say or further exacerbating, okay, or maybe let's say or further making the issue worse. Okay, so I'm saying that remote sensing covers large areas in real time. Okay, and so of course this allows us to track how further is it spreading, or is it spreading? Is the soil erosion spreading? Okay, maybe I should have written that there. Okay, yeah. Okay, and also allows us to prevent or avoid being in contact, or further making the issue worse. Okay, because when you are there, you're stepping on that land, you probably creating more patches of land, creating more erosion. Okay, so us being at a distance allows us to effectively monitor without actually being in contact, or actually as I said, making it worse. Okay, so we basically carry out this as an experiment that is going to be hindered, that will not have anyone involved in this monitoring, anyone actually being in contact, or further worsening the issue. Okay, in this case, the soil erosion. Right, so that's 1 mark, that's 2 marks actually. Okay, so that's, yeah, okay. Okay, next question. So the municipality provides a GIS specialist with the topographical map and orthophoto map to check the availability of water at Dam G. Okay, which dam are we talking about? No, it's actually Dam J. So at Dam J, right? So this is the dam that we are referring to, that we're talking about. And it's actually this, because this is also the area of the orthophoto map, we should also be able to find this dam here at the bottom. Yes, yeah, this is the dam we're talking about. It's 11 on the orthophoto map. Okay, cool. availability of water. Okay, so 3.3.3 says define the concept raster data. Okay, define the concept raster data. Okay, so this is a definition. So raster data, guys, 3.3.3, data represented by pixels or grid of cells. Grid of cells. Okay, so that should be it. That's is what raster data is, guys. Or by pictures, represented by pictures or images. Okay, and then 3.3.4, a topographical map or orthophoto map is a representation of raster data. Okay, so of course, guys, this is an orthophoto map, right? An orthophoto map is what? That's a picture, that's a photograph, right? So a photograph is made of what? Pixels. It's made up, those are like the tiny cells, okay? Like when you look at, for an example, matter, like everything that is made up, it's made up of atoms, it's made up of particles, it's made up of cells, okay? So when it comes to a picture, it's made up of pixels, okay? And so, of course, that further goes on to speak on about to resolution and so on and so on. But for this, for the topographical map, this is represented by lines, by polygons, by points. Okay, so this is vector data. Okay, this is actually vector data, and this is raster data. Okay, so you cannot go wrong there, guys. So it has to be in the orthophoto map. Okay, that's a representation of the raster data. Then 3.3.5. Wait, is this the last question? Wow. Okay. Wow. Okay. We've gone really far. Okay. So why is the 3.3.5 final question? Why is the information on the orthophoto map more realistic when determining the availability of water in the dam at a specific time? So why is the information on the orthophoto map more realistic, okay, when determining the availability of water in the dam at a specific time? Okay, right. Okay, okay, so basically this is how I would explain it, okay? So with the picture, guys, with like raster data, you can get the availability of water, okay? So for an example, if I would draw maybe two dams here, okay? Say maybe this was basically a picture, not what I'm drawing here. And this had this shade of color, and then this had, the second dam had this shade of color. Okay, so which one would you say has a higher availability of water? Of course, you would say this one because it is darker. Okay, so because dark colored water indicates a deep depth, or maybe let's rather say, or a big availability of water, and a lighter shade of color represents shallow water. This information gives us realistic information